Hi viewers, in today's class I am going to discuss on the concept antenna arrays. So all of you have heard about the term array. Array means generally what we say just it is a group. That means here we can understand that in our class today we are going to discuss on antenna that is used as a group. So first we will get a doubt why we need to use our antenna as a group. So before going to clarification of that, first we will see the definition of antenna array and we will move to the concept. You can just see here the definition. An antenna array is a set of antennas or group of antennas connected and arranged in a regular structure to form a single antenna that can be capture and transmit signals in different directions. So I will just simplify this definition. You see here we are saying that an array is a set of antennas which are connected and arranged in a particular structure. It means what we can get from this diagram we will see. See here in this diagram you can see all these are the single antennas or monopole antennas. Here you can see that each and every antenna operates individually. So they are not linked or connected to any other antennas. This we can go for example of monopole antennas or dipole antennas or whip antennas in that way. So here away from this type of pattern we are going into a new pattern called group of antennas. So group of antennas, just I have given you here two reference images. In the above diagram what we have seen a single antenna, but you can see here multiple antennas connected just like a single antenna. So here if you go back to our definition what we have said, array is a set of antennas connected and arranged in a regular structure. See in this diagram also we can say that in this diagram we can say the group of our antennas are arranged in a particular structure or pattern. So here the arrangement of antennas is very important. Just like that we cannot get some group of antennas and place randomly and we cannot expect a radiation pattern. So there should be particular format or structure like this. So there are different ways of arrangement of antennas that we can see later. And here the regular structure to form a single antenna. And these type of antennas are capable of transmitting or receiving signals from different directions. So this is the basic definition of antenna array. In a single word, it is a group of antenna that operates like a single antenna, right? In a simplified way. And our first point is what is the necessity of this antenna array? Why can't we use a single antenna for all purposes? Here we can take an example and understand this concept very clearly. See, I am just giving the diagram of a small antenna. As you are all aware that this is a half wave dipole antenna. And you know the radiation pattern for this antenna, how we get like this. And what we call these type of pattern, like omnidirectional pattern, or some ways we will be calling as donut shape, anyhow. And you can see clearly almost it is nearly like circular type of radiation pattern. And for this type of pattern, can we expect very high gain and high directivity? Is it possible? Not possible. Why? Because in these particular cases, gain cannot be and directivity cannot be very high. But in our practical applications, what happens? Mostly we will be going for long distance communication that you are all aware nowadays. We are communicating throughout worldwide. In such cases, we need very high gain as well as directivity. So in such cases, we may think that a single antenna size, if you go on increasing, automatically the gain and directivity increases. That point everyone will accept. The same antenna size, if I am go on increasing, automatically the radiation pattern enlarges like this. But is it possible to increase the size of antenna in all cases? Why? Because if we are go on increasing the electrical size of antenna, what happens? It may not be compatible for all applications. Just if you take example of a mobile, in mobile is it possible to use a very large size of antennas? It is not possible. In such a way, if you go for space related application or radar communication, there weight and space are most important and crucial factors. In such type of cases, automatically we go for other alternative arrangements. From all these aspects only, this array concept has came out. So always we know that necessity always leads to some new invention. In that aspect only this antenna arrays came out. See here the same single antenna, how it has changed its pattern, I will show in group of antennas. The same dipoles, just I have taken in a group, just for example only. So if I operate all this group as a single antenna, automatically my radiation pattern takes this form. Can you see the difference in antenna pattern? Here it is almost omnidirectional, but here it is showing some pointed direction in a particular pointedly in particular direction with small side lobes. This is just an example pattern. In this case what happens? My directivity increases. Obviously as it is directly proportional to gain, it also increases. This is the concept of antenna array. And why nowadays this antenna array concept is becoming popular is we can list out so many advantages and disadvantages regarding this. That only I am going to discuss now. Once again you can just have a look at the diagrams. All these are set of monopole or dipole single antennas which where we can see very low gain and low directivity. As you come for the case of the multiple antennas that can be arranged like this, I have just shown you the example of images, and see here all the antennas are placed like this, and these all will operate like a single antenna. That is a concept of arrays, right? So if you come for just overview of this antenna array, whenever a single element gain is not sufficient, there the alternative is an antenna array. Here single element means nothing but single antenna element, right? If I am going to use a simple dipole antenna and I am unable to achieve my gain, in those cases I start increasing the number of antennas. Simple solution, right? And next, antenna array is a radiating system that has individual radiators. You can see this point. It is nothing but a system, radiating system, where a group of radiators means nothing but antennas, group of antennas will be operated. All this group collectively forms the final radiation pattern, and in such a group each radiator works with its own induction field. That means, for example, I am having some group of antennas like this, group of antennas like this. Each and every antenna has its own pattern. Why? Because this is a single dipole, this is a single dipole, this is also a dipole, and as well as this. So each and every antenna starts showing its radiation like this, like this. So what happens? All these radiation patterns will form a sum up like this. Finally what happens? All these radiation patterns will be added in forward direction and you will get a final radiation pattern. So that is the concept here we are having for antenna array. And while using this antenna array concept, there are so many important things that we need to keep in mind. How we can get a perfect pattern of radiation, that we will discuss in the next class. But now today I want to just have a glimpse on advantages and disadvantages of this antenna arrays. First, see, we will list out the advantages. You can see here the first point I have mentioned is increased directivity. This is very important requirement for all outside world applications. Why? Because for increasing in directivity improves the output of any application. And flexibility in design. Flexibility in design means how much easily we can have the antenna designing, that is group of antenna designing. As directivity increases, automatically gain also increases. And you can observe here, we are going to have a better control for beam direction with multiple radiators. That means while using group of radiators, in which particular direction I want my output radiation or beam radiation, that can be changed very easily in this antenna array mechanism. Increased signal strength, automatically there is improvement in the signal to noise ratio also. These are the list of advantages, and we will go for disadvantages. Here the first point we have mentioned is resistive losses are high. That means nothing but as we are go on increasing the number of elements, Element is nothing but conductor, right? So each and every individual conductor has some amount of losses. As a group, what happens automatically? The resistive losses go on increasing. And next point is huge space is required, that you can observe from the diagram itself. See here what is the occupancy of space and here what is the occupancy of space, that usually happens. And third point is difficulty in mounting and maintenance. This is the most important thing we need to observe. And while you are using antenna arrays, the arrangement of antennas and how you cope up with all the antennas, that is a little bit difficult task. Why? Because all the antennas you need to arrange in a particular pattern, that is very important. So these are the just important key points regarding the antenna arrays. In my next class, I'll give how to achieve the perfect radiation pattern from antenna arrays. Okay, thank you.